All right, good afternoon, ladies and gentlemen. Our objective for today is that students will be able to examine the effects that different initial values have on the value of investments with the same growth factor. So we're going to look at two examples of an investment of money over time that has two different initial values, but the growth factor is the same for both of those. All right, so just to review the lesson that we saw yesterday, remember we saw the price of a stamp. It was increasing over time and had a 6% growth rate every year, right? And what happened in that scenario is we saw that every single year you're kind of building interest on your interest. So it didn't always keep increasing by the same amount because we kept finding 6% of what we had that current year. So that type of growth is referred to as compound growth because the interest is compounding on top of itself over and over again. Now, for the investigation for today, it says here that Babcha started a college fund for her two granddaughters. She gave $1,250 to Penelope and $2,500 to Natalia. Babcha invested in 10-year bonds that pay 4% interest a year. Okay, so we kind of talked about bonds a little bit when we had our unit on finance. A bond is basically kind of like a savings account, but you can't touch the money for 10 years. So the money goes in, you don't touch it, but over those 10 years, every year it's gaining 4% interest on the money that's in the account, all right? First thing you're gonna do is just identify a couple of things. First is, what are the girls' initial values? So these numbers are obviously written in this paragraph here. I want you to just write down the initial value for Penelope, the initial value for Natalia there. Then the second one, what are the growth rates, right? There's actually only one growth rate here. They both have the same growth rate. Remember when we talk about growth rate, it is a percentage, right? There's only one percentage listed there, so write that down here, right? Now, growth factor, I'm gonna help you out with it just to make sure that you have it because you need that for this next part, right? Remember, there's an intimate relationship between the growth rate and the growth factor. So the way that you find the growth factor, if you know the growth rate, is first, you need to turn your growth rate into a decimal. So the growth rate was 4%. 4% as a decimal, I would do 4% divided by 100 gives me 0.04, right? But to get to our growth factor, we actually have to add 1 to that. So it's not 0.04, it is 1.04. So right now we know the growth factor, we know the initial values. That is enough information to build our equations, which is what we're going to do on the next page, okay? So just to remind you, right, our exponential equations always take this form. Your dependent variable is equal to your initial value multiplied by your growth factor, and the exponent is the independent variable, all right? So I still see people messing this up. Basically, they need to be letters because those are your variables. A and B, those should be numbers because it's your initial value and your growth factor. So again, try not to mess that up. That means that when I'm looking at my equation here for Penelope, this right here and this right here are going to be letters. Those are my variables. These two boxes are going to be my initial value and my growth factor, so these two are numbers. Please try not to get that mixed up. Now, to figure out which letters go where, remember, I need to figure out which variable depends on the other one. So I have two variables, M and N, right? M is the amount of money, N is the number of years. So does the amount of money in the account depend on how many years have passed, or does how many years that have passed depend on the amount of money in the account? Right? Only one of those ways makes sense. I'm going to give you the first one. You're going to come up with the next one yourself, right? If you think you know how to do it, do that yourself first before I see it, before I show it to you, right? So Penelope's equation looks like M is equal to, her initial value was $1,250. The growth factor, not rate, was 1.04. The independent variable is the number of years N. right? Your equation is as simple as that, people. Now, do the same thing for Natalia. And the next thing that you're going to do is fill out this table here to show how the money is growing over time. I'm going to help you get you started on Penelope's equation, and then you're going to do Natalia's equation on your own. So the first thing is to figure out what is the initial value here. How much money are we starting with, right? Good thing is that we actually already found that information, right? And that information is right here. So Penelope started off with $1,250 in her account with a growth rate of 1.04. All that we need to do is multiply this result by 1.04. That's going to tell me how much she has. So 1,250 times 1.04, boom, $1,300. Do the same thing again. From this year to the next year, I multiply by 1.04. So in my calculator, I actually just need to do this, times 1.04. There we go, 1,352. Rinse and repeat. Keep doing this until you get down to year 10, right? Because it's a 10-year savings bond. So I can't touch the money until we're at year 10, right? Finish filling this table out here. Do the same thing for Natalia's savings. And then you're going to compare to see how the investments changed over time, right? You're going to do that comparison on the next page. Okay, so let me just explain very clearly what I want you to do here, right? First one, it says, by how much money did Penelope's fund increase from year 0 to year 1? So from year 0 to year 1, I know that it increased by 4%, but I'm actually asking you by how much money, right? So from $1,250 to $1,300, what is the increase? How much did we add, right? Same thing for Natalia. From year 0 to year 1, how much did it increase by? Then for Penelope and Natalia, looking at the last 2 years, from year 9 to year 10, again, how much did we increase by from this year to this year, right? The reason why I'm asking you about those numbers there is so that you can answer the next couple of questions, right? So question 5 says, does one of the girls' funds appear to be increasing at a faster rate, right? So when you find those numbers, that's going to tell you how much it increased by. Is one moving at a faster rate than the other, okay? Once you have that question answered, the next question is, how do you think the initial value of the fund affected the yearly value increase, right? So how did these two initial values affect how much we added from year to year, right? Do you notice a pattern there that shows you the effect, right? The next one then is, how does the initial value of the fund affect the final value? So comparing the initial value here to the final value here, and the same thing for the initial value for Natalia's to the final value of Natalia's, what impact did the difference in the initial values play in the final value, right? And then the last question is just saying, suppose that we have a different investment amount. How much money do you predict there's going to be in the account after 10 years, assuming that it had the same interest rate as before, right? And there's a relationship between this $5,000 and these numbers here, right? So what's the relationship? What do you think the value is going to be? And you shouldn't need to use the equation to figure that out, right? You actually can, if you want, write out an equation for this using the numbers that you have, and then use the equation to determine how much money is there in 10 years, but that's not the goal, right? I want you to use the relationship that you see between these two tables to try to figure that part out, all right? If you have any questions, the Zoom session will be open at 12:30. Good luck.